Bismillahirrahmanirrahim. Assalamualaikum. Hello everyone. So what we're going to do in this video is to apply the concept of definite integrals as the way to find the area under the curve. Okay, so let me get the slides on. So area between the curves. Okay, so so far what we have done previously, we know that the definite integral represents the sum of the area between the graph f of x and the x-axis. So it is always the area between the curve, okay, f of x and the x-axis. Okay, so if this is A and this is B, it is always this area. Okay, and we already also know that the area above the x-axis are counted positively. Okay, as shown in the here. Okay, because the height of the be measured in positive number, while the area below the x-axis will be counted negatively because the height of these rectangles are measured negatively because they are below the x-axis. Okay, so in this section, we're going to use the definite integral to find the actual area between a curve and the x-axis, or the actual area between the two curves. And these areas, so make sure the areas are always non-negative quantities. Area can never be negative. Okay, it's just that sometimes when we do the calculation, it can be negative because of the unit that we use. The height is in the negative. So for example, let's consider the area shown in the figure. Okay, that is founded by f of x and g of x. Okay, so let's say we are interested to find the area A. So how do we find the area A between A and B? So this is small a. It is missed here. Okay. So A, the lower limit. Okay. So the area A between fx and gx, basically what we can do is that we can find the area under this whole curve, okay, under f of x, this whole area, and then we subtract the area under the gx. Okay, the area under gx, and this can give us basically the intended area. We just want to find the blue area, not the whole part, right? So to find the blue area, first we need to find the whole area under f of x and subtract the area of gx within the same range from a to b. Okay, so this gives us the theorem 1 on the area between the two curves. If we have two functions that are continuous over the interval a b, where function f is higher than function g, then the area bounded, okay, by these two functions, okay, can be found when we subtract the area. So first we find the total area under f, and then we subtract the area of g. Okay. So just take note that the theorem require the graph of function f to be above the graph g throughout the interval a and b. Okay, a and b. Okay. So the functions f and g can either be positive, negative, or zero, but as long as the function f must be above g. Okay. So let's have a look at this example 1. So let's say we want to find the area bounded by this function 6x minus x squared and y0 for this interval from 1 to 4. So this is our lower limit, this is our upper limit from 1 to 4, and this is how the graph looks like. Okay, it is a quadratic function 6x minus x squared. So we want to basically find this area. So how do we do this? So we can simply apply the definite integral, right? So the lower limit, upper limit, 6x minus x squared, and then we find we integrate this, we find the antiderivative, and then we evaluate them. We simply find the value of the antiderivative, okay, from the upper limit, and then subtract the value of the antiderivative evaluated at the lower limit. Okay, so we get 24. Okay. Now, this will be much more interesting. So let's say we have this function x squared minus 2x, okay, over the interval 1 and 2. So when we draw the graph, this is how the graph looks like, and we simply want to focus from 1 to 2. This is 1 and this is 2. So only this part, okay, this part. So it is the shaded region represented by this notation a1, by this term a1. Since this function is negative, within this interval from 1 to 2, the function is below the x-axis. So we need to basically integrate the negative of the function. Okay, so whenever you want to find the area of when the curve is under the x-axis, so don't forget the negative sign. Okay, the negative sign here. So multiply by -1, so this become 2x minus x squared from 1 to 2. Okay, so when you do this, you should be able to get, so this is this area. Okay, now let's say now we change the interval from -1 to 1. So this is 1. So we simply want to know a2 and a3. Now this involves a change in the function where from -1 to 0, the function is positive. Okay, but from 0 to 1, the function is negative. So what we can do is that we can find them, we can find the area one by one. So the area will be a2 plus a3. Okay, now remember we are finding the area. It's not about the definite integral. We simply use the definite integral to find the area. So for A2, since it is positive, we can directly just make sure you use the right upper bound, okay, the upper limit, which is from -1 to 0, okay, and then find the antiderivative. But for for A3, don't forget the negative sign. Okay, don't forget the negative sign. So in total, this is what we need to do. So we have we have to do two integrations. Okay, find the respective value of the antiderivative. So this will be from 0 to negative, from -1 to 0, and this is will be from 0 to 1. Okay, you just plug them in. Okay, and you should be able to get the answer would be 2. Okay. Okay, another example 3. So let's say the intended area would be the area bounded by the graph, okay, fx and gx from -2 to 1. So when we draw the graph, this is how the graph looks like. So we are interested to find this area A, okay, this area A. So the shaded region, okay, is the intended region that we want to find. So you can see that f of x is always positive and it is always greater than g of x throughout this region from -2 to 1. Okay, f of x is always above g of x. Then we can use theorem 1. Okay, we can use theorem 1 where we can simply find the area, the whole area under f of x and then subtract the area of gx. Okay, and so from -2 to 1, so this is the, we simply put in f of x here and subtract gx. Okay, and simplify it first. Okay, we can, you know, these two can be simplified. Okay, open the bracket, and then we find the antiderivative of this function evaluated from -2 to 1. Okay, from -2 to 1, and you should get 8.25. Okay. Now, example 4, find the area bounded by these two functions, okay, fx and gx. Okay, so the graph f and g, okay, we first of all we draw the graph, okay, and it's shown here, okay, and we simply want to find this specific area, right, that is between these two curves, okay, between these two curves. So again, what we can do is that we know the, first of all, you need to find the intersection points so that we can identify the lower limit and the upper limit, right? This is the lower limit and upper limit. So how do you find this? I mean, because in this question, okay, the lower limit and the upper limit are not given. So you need to solve it. What is, we know that we only want to find the area between these two curves. We have two curves and we simply want to find the area that is closed by these two curves, by these two functions. Okay, so first of all, we find the intersection point. And then we know that f of x is always above g of x within this interval, -1 and 3. Okay, so how do we find it? We can apply theorem 1 and we can simplify the problem where we subtract gx from f of x. And then we simply find the antiderivative and evaluate them at the upper limit and the lower limit. Okay, so the area of A would be 10.667. Okay. Another example, so the area between this curve. Okay, so let's say we want to find the area bounded by these two curves, x squared minus x and gx equals 2x. Okay, so it is shown in this figure. And here we have two regions, A1 and A2, where for A1, f of x is above g of x, but for A2, gx is above. Okay, so for here, you should be able to see that for A1, f of x is greater than g of x, but for A2 is the other way around, gx greater than f of x. So now we can apply theorem 1, but we have to do it separately. So first of all, we need to find A1. Okay, for A1, f of x is above gx, so we simply subtract gx from f of x and evaluate it, okay, specifically within this interval from -2 to 0, because it is only within this region that f of x is above g of x. Okay, so once we have done that, subtract that, we can simply find the antiderivative, right? So x to the power of 3 over 3 minus 3 over 2 x squared, evaluated from -2 to 0. And this is our A1. A1. What about A2? Now, A2, we can also apply theorem 1, but we have to subtract f of x from gx, because at A2, gx is now above f of x. Okay, so we simply subtract f of x, x squared minus x, from 2x, and then we find the antiderivative, evaluate it from 0 to 3. Okay, so we get 4.5. Now to find, don't forget to sum them up. So A1 plus A2 will give us 13.167. Okay, these other examples, I'm going to leave it to you, okay, for your own exploration. So especially the this application example, where we apply the Lorentz curve. Lorentz curve in economics. We use Lorentz curve to measure income, to represent income inequality. Okay, and we're always interested to find the area, okay, between these two curves. The curve of absolute equality, y equals x, and the Lorentz curve. Okay, so I think that's it for this topic. Okay, and so please try to do some examples to make sure you are familiar with how to find the intended. So first of all, you need to make sure you identify the right area, and don't forget if the area is if the curve is below the x-axis, don't forget the negative sign, because area can never be negative. And make sure when you want to apply theorem 1, okay, one function must always be above the other function, and so that you can simplify the calculation. So that's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.